Okay. Now, previously, we learned about P chart. P chart is defect proportional, which is in percentage. Okay, so you need three important lines, which is the mean, or in this case, X bar or P, like I see on the screen. And I will just write P because it's a P chart. Then you have two limit, which is a upper control limit, lower control limit. Okay. And to build this one, you need to calculate percentage of defect. Okay. So percentage, proportional defect, not percentage, proportional defect. Okay, proportional defect is number of sample, right, total number sample divided by the defect. Okay. So in this case, like for example, sample 1, number of defects 6, proportional is 0.06. Why? Because each time you take one sample is 100 genes. So you get total number of sample. For example, 6 divided by 100, you get 0.06. Okay. Then the equation to calculate UCL and LCL is P bar plus minus Z sigma P, with your sigma P equal to square root P1 minus P bar divided by N. Okay. So these are the things that is important. So how do I give you marks in exam? Axis will be 1 mark. All this will be 1 mark. Okay, so all the numbers here is important. Then you calculate the defect. Okay, this one, calculate defect. Depends on data. So for example, 20, it will be about 5 marks or 8 marks. It depends on the numbers of defect you need to calculate. Then this one is another 1 mark. So here got 2 marks here. So it's quite easy to score for this kind of question. So 1, 2, 3, 4, 5, 6, 7. About 12 marks for the calculation. And then we're expecting you to tell me the trend and solution, what you need to do. Okay, so the trend, you need to answer whether in control or not in control. Solution, what you need to do, or what actually happened. So solution, trend, in control, not in control, go up or go down, moving towards or distributed well in the mean region, or moving towards UCL, or moving towards LCL. Okay, so this will be the last section of your question or your solution. So all this you build chart, you calculate the proportional defect, depend on the point. Then you calculate the UCL, and you tell me from the graph. So you tell me whether the trend either in control, how many in control, how many out control, or in overall the trend is going up, going down, or going up to where? And must tell me the direction. Going up to UCL, or have a tendency to go down, moving towards LCL, or you can tell the trend is in control and the data is well distributed in the mean region. Okay, so you need to describe what mean by in control. So there are 4 criteria in my slides. Y is in control. Okay, you need to use that four point there to explain why is in control. Okay, then if it's in control, then your solution only one, continue to monitor. Okay, if it's out of control, then you see you need to make the adjustment. If it's upper limit, what do you mean? What can you do? You need to alert the operator, or you need to make adjustment to the machine so that the trend can be moved down or moved towards the mean. Your solution, you want to, the solution main thing is you want to fix the either go up or go down trend. Move it to the mean. Okay, move it to the mean. Okay. Yeah. Okay, so these are the recap or review of what we have covered for the previous lecture. All the formula won't be given, so we expect you to memorize. Not a difficult equation, by the way. Okay. All right. All this lah, all the expected answer lah. So we already covered in the previous lecture. Today we focus on a chart called C chart. C chart, the y-axis is number of defective item in sample versus number sample. Okay, so it looks something like this. Quite similar with P chart, only you need to be careful on the y-axis. Okay. So when we use C chart, a C chart is used when it's not possible to compute a proportional defective and the actual numbers of defect must be used. Okay. For example, when you do paint job, the number of defects on the paint can be counted for each car, but proportional cannot be computed. You cannot count like, okay, one car got how many portion. You cannot say because the paint job, sometimes it was on the left hand side, sometimes on the right hand side, sometimes at the top. So you actually given the calculation more complex. So you can simplify the calculation or the observation to C chart. For example, paint job. So these are the equation for C chart. C chart, you need ULC, LCL. Okay, C chart, C and X. So this is C chart. So again, you need the mean. So I just write C as a mean. On the top, you see is upper control limit. Lower one is lower control limit. And you're given the UCL equal to C bar and LCL plus minus ZC. So again, the number of jack is depend on the distribution percentage you want to calculate. If it's 99 point something, is Z equal to 3. If it's 80 something or 80 something, it will be 2. If it's 1, then it's about 60 something. Okay, so remember this one. So Z number won't be given. You need to read from the question, right? Z number you need to read from the table. Okay, so the Z, the standard variation will be for C chart is a bit different compared to P chart. So for C chart, your standard variation will be square root of your mean. Okay, if you compare to the P chart is quite complex. Mean bracket 1 minus mean divided by n, but C chart is more simpler. Okay, so for example, this one is a lengthy statement. Is in the hotel scenario. So one hotel is have one hotel. So total you have 240 room. Hotel housekeeping department is responsible for the cleanliness. Each individual housekeeper housekeeper is responsible for 20 rooms. Every room in use is thoroughly clean, blah, 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 restored. Any defect that the housekeeping staff notice that are not part of the normal housekeeping are proposed to report to the hotel management. So if you find something, you report to maintenance. Every room is briefly inspect each day. So each day, inspect. Okay. By housekeeping, each room is briefly inspected by housekeeping supervisor. However, hotel management also conduct inspection tour at random for detail. So plus random tour by management. Okay. The management inspector not only check for normal housekeeping services, defect like clean sheet, dust, towels, but also defect by operative, missing, TV, and so on. Okay, blah, blah, blah. These are the defects. An inspection sample include 12 room. The sample includes 12 room. That is one room selected randomly. From each of the 12, 20 room blocks serviced by the housekeeper. Okay, so read again. An inspection sample include 12 room. That is one room selected randomly from each of the 20 rooms. So this one, each housekeeping need to service 20 room. So this one room is randomly picked. Okay, randomly picked from these 20 rooms. Okay, and this inspection is done by management. Following are the result of 15 inspection sample conducted at random during 1 month period. So you are given a defect table. So 15 inspection was done at random during 1 month period. Okay. So you have sample 1 to 15. Number of defect. So first sample means first day, we go and inspect. Out of 20 room, 12 defect detected on the first inspection. Okay, second day, 8 defect and so on. So total defect is 190 in the inspector report for the 15 sample. Okay, so this one 15 inspection. Okay. The hotel believe that approximate 99% of defect respond. Of course, in exam you won't see this bracket. Right, I will remove this one in the exam. Approximate 90% of the defect are caused by natural random variation. Means you are looking at Z 99%, means your Z equal 3. Right? Okay. With 1% caused by non-random variabilities. So we are not concerned about 1%. We are more concerned on Z. They want to construct C chart to monitor the housekeeping services. Okay. So you need to look at the table and build. Typo error here, it should be C bar, right? So C bar is the average value, is not known, the sample estimate C bar can be used instead. So because the population, the population process average is not known, so you can just estimate C bar by using 190 divided by 15 sample. So your average will be 12.67 defect in every inspection. In this 15 inspection, in average, every time you go in a room, there will be around 13 defect. 13 defect. Okay. The control limits are compute using Z equal 3 because 99% is random data. So we use this formula, C plus minus Z sigma C. So you know how to calculate sigma C already, which is the square root of this number. Okay. You substitute the value, UCL will be 23 point something, LCL will be 1.99 something. So if can, use 3 decimal place or 3 significant figure. In this case, is you can 3 decimal place to be more accurate. Okay, so then you transfer all these C bar, UCL, LCL onto the chart. Okay, onto the chart. So you know that the minimum value is about 2, maximum is about 24. So you use your ruler, go and estimate around the data. So 0 is still start from 0, but you estimate the range of your y-axis. Then you have 15 sample. Okay. So the figure will look like something like this. Okay. Mean you already calculate 12 point something. UCL 23, LCL about 2. Then the number of sample will be 15, about 15 here. So you plot 1 to 15. Then you see number 1 is 12. So 1 go to 12, 2 go to 10, 8, and so on. C chart is more direct. More direct. Okay. And after that, you do diagnostic. You do your evaluation. Okay. Now, if you are technician or you're technical technician, you only need to know how to plot chart. But if you're taking engineering courses, you need to know to do analysis and give solution. You see problems, you're able to detect problems, give solution. So if you look at C chart, is there any problems? Is the process in control? Yes or no? Addition? Is the data in control? In control, out control? And why? Look at this chart, this table. If your worker, hey, boss, I give you the data to see. So is it in control or not in control? In control, why? No. If you write this answer in your solution, no marks for that. Why in control? It's like playing badminton. How you know the ball, the badminton is the ball or is out, the player is out or in. You look at the line, right? So it's all the dot is inside or outside. So you need to mention. So the answer is in control. Why? Because all the 15 dot or 15 data is stay within UCL and LCL. You need to mention this statement. Huh? If you explain something else, then no marks for the trend. Okay, yeah? So at the end, all this P chart, C chart, you still need to tell us whether in control or not. Okay, so it is in control because it's within UCL, LCL, and you need to tell the trend of the data. Where does it accumulate? Does it accumulate on the top or below or in the middle. So in this one, you can say the room defect data stay within the mean line. Okay, then you count how many below, how many up. So there are 4 rules in my slides. You need to go and see what are the in control data. So you count 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So 8 on the top, 7 at the below. Quite balanced. Okay. Okay. So all samples, room quality is in control. The chart can consider reliability and monitoring the room quality is in future. So if it's a control, only one solution, continue to monitor. Okay, if out control, you need to give solution, right? Like for example, if this chart out control, what is your solution for hotel cleanliness situation? What is your solution? This not your first time late, Don't do that, Next class you late more than 24 minutes, you consider absent, Lee Kim Hian? Lee Kim Hian here or not? Lee Kim Hian. If the C chart go like that, C and X, if you're seeing this trend, what is the solution you can suggest? Give more detailed explanation on parameter. You need to consider the statement, the scenario. If you give something very general, you won't score marks one. This is a hotel housekeeping issue. If you see this trend go up and it break UCL already, what can you do to make this one in control? Huh? How you monitor? Not only again, you only say monitor when the data is in control. In management, in project management, when you use the word monitor, it means your data are good, stable, and in control. No, you already see you already have the data already. Why you need to monitor? You already seen the data out control already. So monitor won't solve the problem. Means you just put your hand inside your pocket and okay let's see what happen and then customer will keep complaining to your hotel and no more business already. So what is your solution if this one is the housekeeping issue and it's go out of control? What is your solution if the trend go outside like what I draw on the whiteboard? Okay, so you are still outside we are training you to become a project manager or management level kind of thinking. You already show problem in the hotel already. The defect, what are the defects? You see, the statement here give you a lot of details already. All this data, what they check? Clean sheet, dust room, all this blah blah blah, missing TV, poor picture, reception, all these things. You already see this one, all this defect already escalating to out control level already. So what is your solution? What actually happened if you have this, all this always have TV missing, always have no clean sheet, all these things. You imagine yourself, you are the customers, and how you improve as a management of hotel. Okay, training must be there. What else? Huh? Okay, maybe there's no standard there, so you need to set the standard. Okay, so training and standard. What else? Okay, increase security, because this one include something missing. So how do you secure? How do you avoid missing TV? TV is quite big. You want to steal also very hard, but it still happen. TV remote missing. So how do you prevent TV remote from missing? Yeah. Okay. So this one you need to mention, to avoid TV remote missing. So there is a checklist when you check out from the hotel. So you make sure the housekeeper go inside the room, follow a checklist, whether TV remote is there or not. If not, then apply fine of some fees or penalties. So this one you need to think, solution, at least 2 or 3 solutions to that. Don't beat around the bush. You need to see the statement, then try to think, how do I avoid defective lamp? How do I fix all these things? Pick 1 or 2 problems, then think how you fix. Okay. Okay. So C chart, no problem. Okay, the rest is theory. Who haven't signed? So you sign. Okay. Two common variable control chart, R chart, and mean chart. So this is just information for you lah. Mean chart, usually the sample taken tend to be small, usually about 4 to 5. So if standard variation is known from the past historical, then formula using standard variation can be used. If the standard variation is not known, then table of value based on sample range is available to develop the upper lower limit control. Okay. So this is a mean chart lah. Okay. So mean chart, you have UCL, LCL also, but you are using mean of the mean. You see double line here? You're using mean of the mean. Okay. So another chart called mean chart. Mean chart. UCL, LCL, double X plus minus Z sigma X bar. Okay. So X double means you take the average, then average again. Okay. You add all the average, then divide by the sample of the group. Standard variation is sigma divided by square root of K. This one. Sigma X bar. This one is sigma divided by square root of K. Okay, so let's say he asks you to construct a mean chart. Okay, a mean chart, X bar chart. So you're given a scenario where it's the two company. So it's doing bearing and you want to do monitoring. Okay. So it's more like bearing so and so, blah blah blah. So given you a scenario, employee have taken 10 sample during 10-day period and 5 slip ring bearing and measured the diameters of bearing. Individual observation is given in the table. Okay, so you're given 10 sample and then you measure, each time you measure five sample. So like you're doing experiment in your engineering lab. You take one and then you measure 3 times, at least minimum 3 times, and divide by 3. Right. This one in the industry normally more than 3 times. In this case, example 3, measure 5 times. So take for 10 sample, 10 days. So one day you take one sample. Okay. From past historical data is known. So past historical is known that the process standard variation is given 0.8. So standard variation is given. Standard variation is given. So you can find the sigma x bar. Standard variation is known, is given. The company want to develop a control chart with 3 sigma. Okay, it give you want to develop a control chart. Control chart, not C chart. C chart is not control chart. Don't confuse C chart and the control chart. Different. P chart, C chart, and then mean chart. Control chart can be any of P, C, and mean. These 3 also means control chart. Okay, with 3 sigma. 3 sigma, usually we don't give this information in the exam. We will give you 99% or 80 something percent, 65%, right? To monitor the process in the future. So here we use the formula, right? Mean of, so each one of this one. So in the test, you'll be given sample data 1 to 5. I will remove this column. You need to find the average of this number. Okay, in test you won't see this one. I will remove the mean value. Okay, so data 1, 2, 3, 4, 1 under 10, and then 5 sample, and then you need to calculate the mean. Careless mistake I've seen when you calculate one of these. So always check. One single mistakes, it will destroy the rest of the answer. So it can do 3 decimal place, right? Or 3 significant figure. So I believe no issue on calculating this one. Means you add 2.0, 5.02, 5.01, blah, 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 until 5 divided by 5, you get 4.98. Then do the rest until 10. Then you group all the mean together. You get 15.09. Okay. So mean of the mean, so double X bar X equal to all the mean add together 55.09 divided by 10 data. So X double bar is 5.01 and calculate the UCL and LCL. So UCL is upper, so positive, equal to Z equal to 3. Sigma X is standard variation divided by square root of K. You have 10 sample. Okay, do the positive one for UCL, do the negative for LCL. So you have 2 data, 5 point something, 4 point something. It's quite near. It's quite near. And this one you usually in the precision manufacturing. Okay, so you have a very, very near UFC, UCL. Okay, and X bar. So you have 3 important line, X double bar, UCL, LCL. You plot inside the graph. Okay, sometimes you don't need to plot graph, you just observe from this 3 value. right? So you want to see upper limit 5.09, you look at average. If there anything out of 5.09, no, there's one very near. 4.93, lower limit. Is there anything less than 4.93? No, right? But you can see the data, most of the data will moving towards this one by reading the numerical data. Okay, so none of the sample fall outside, so the process is in control. Okay. So this is standard variation is known lah in this case, So if the standard variation is not known, then a table of value based on sample range is available to develop the upper limit control. So in the second approach, we use this formula to control. So this one, the question will give you standard variation with historical data is available. You use this approach, you use this formula, you use the ZZ. However, you see the same data, but it mentions something in the statement. Standard variation is not known or unknown, and the table of value based on sample range is available to develop the upper and lower limits. You using this formula, you change the Z to A2. If standard variation unknown, you are using X double bar plus minus no zoom all Z, you use A sigma. Change the sigma into R bar. This one you need to refer to a new table. Okay. R is average range value. X bar is calculate from the mean. A2 is from the table. It's from the table. These are the tables. You will see this one. If you see this one in the question, you need to read carefully whether the data is available, the standard version is available or not available. If sometimes we trick you by putting this one in the question, but actually you don't need this table. Something will be tricky question. I might put this table in the example just now. This one, example 3. Okay. Don't use this table in example 3 question. Example 3, you already know the standard variation. The historical data is known and standard variation is given. So use that. So just be smart lah. Okay. This actually is a very easy question. So if the question mentioned don't know, standard variation is unknown, straight away go to use data, A and R bar. So how to read this one? So this table standard already, number of size from 2 until 25. Actually, there's a long chart. And factor for X bar and factor for R chart. So here you have 1, 2, 3 column. Read carefully. If the question asks you to plot X bar chart, use A value. If the question asks you to plot R chart, range chart, you use D3, D4 value. Yeah. So this one we further study another 2 more chart from P chart, C chart, mean chart, and then mean chart. You will have known data, known standard variation, unknown standard variation. So this is for unknown standard variation. You use A2 chart. Okay. So let's say we use back the same scenario. Example 4. Same scenario. You have the same data, but now the scenario, I just removed the statement just now. The standard variation is unknown. Okay. So the question also didn't mention anything standard variation. Means you need to use the table already. Okay. I will reserve the R later. I will come back to R. I'll just explain how to use the table. Okay. The R bar is computed by this formula. So you're given the R value is given. So you sum up all the R, you get 1.5 divided by K is 10 sample. So your R range mean is 0.15. You need the R bar together with the A value to calculate for the X double bar value. Okay. Okay. So X double bar, take the mean, all the mean divided by number of sample. In this case, 15.9 divided by 10. All right. So X double bar is 5.01. Okay. Now we start to introduce you how to use the table. You have R bar, you have X double bar. Yeah. So in the table just now, each sample you take 5 times. So n equal 5. Okay, in the table, each one have 5 times. So n equal 5. So you go back to the table. Too fast, huh? You go back to the table, refer to number of sample size, 5. Then you read the A2 number straight from the table. A2 value is 0.58. Yeah, so this value is from the table, from number of n. Quite straightforward lah. Okay. So you have the value. Okay. So you have R bar, X double bar, UCL, LCL. Okay. Then you plot the chart. This is called mean chart or control chart by using X double bar calculation. As you can see here, does the data in control? Does the data in control? Yes, in general, it's in control, but the data is moving towards where? Upper limit. So is the collected 10 sample data is in control. Our chart, another chart, the fourth chart. Our chart is a range chart, the difference between the smallest and largest value in the sample. So UCL, you use D4 R bar. LCL, you use D3 R bar. D4 is upper, D3 is lower. So you look at the table just now. This table at the back. D3 is lower, D4 is upper. Okay. So same, you use the formula. UCL equal to D4 R bar, LCL equal to D3 R bar. And the R bar, like what you did, if you see the R value, sum up all the R value divided by number of sample. Okay. So for example, same data, now develop our chart. You just build our chart. This one is 5 sample again. So read 5, go to D3 and D4. Your D3 value is 0. D4 value is 2.11. Okay. So your UCL is something. LCL is 0. Okay. LCL is 0. And then you plot the chart. Okay. You plot the chart, you'll see something like this. Does the data in control? The answer is yes. It's in control. On the range chart, right? The process seems to be in control, right? So X bar chart, in example 4, the process is going to be out of control. The process is going up already and 1 point touching the line, so it's out of control already. However, the R chart in this example suggests that the process is in control, since none of the range is closed. Okay. Okay. So you see 8 and 9, sample 8 and 9 were relatively narrow. So it means that this sample are relatively high. So use both charts together, provide more complete picture for overall process reliabilities. So you need to monitor the process, especially the last few sample. Okay. Okay, so these are the observation. We call it run. We call it run. The pattern in the control chart is called run. A run. So you have 1, 2, 3, 4 types of run. Okay, so the first one is consistent. Second one is consistent above the center line. This one on the left is consistent below center line. This one, observation consistently increasing, consistently decreasing. So these are the keywords that we use to describe the run in our graph. Okay. Okay. The next one, we want to see whether the process is doing, we're going to do pattern test. So this one will be further, the chart question alone can be from P chart, C chart, mean chart, range chart, then ask you to do pattern test. Okay. So pattern test, the purpose of having pattern test is to determine if the observation within the limit control chart display a non-random pattern. Means non-random means something tricky happened. Means something is not natural. Something that you need to intervene. Something you need to take charge already. Okay, so you will see this one zone for pattern test. This is a process average x double bar. You need to calculate using this formula. One sigma formula is plus 1/3 A2 R bar. Where you get the A2 is from the table. Okay, so on the top of the mean is positive, below the x double bar is negative. So 1/3, 1/3. Then you increase to zone B. Zone B is plus 2/3 A2 R bar. Positive on the top, negative at below. Then the maximum one is 3 sigma. 3 sigma is A2 R bar. Okay, you split into 1/3, 1/3, 1/3. The maximum one is 1. Then this 2/3, 1/3. Okay, 1/3, 2/3, 3/3 is 1. 3/3 is 1. Okay. So after you do your pattern test, you need to tell me what is the distribution of data Either they are in a 1 sigma region. 1 sigma region means in zone C. 2 sigma region means zone B. 3 sigma region is zone A. Okay. The rest you read. Pay attention to these slides. This is important. You need to make argument on your statement. A general guidelines here to determine whether the pattern when none of the observations are beyond the control limit. Okay. First rules, 8 consecutive points are on one side of the center line. You observe if this one happen or not. You count is there any 8 consecutive point? Consecutive point means continuously. Point 1, point 2, point 3, point 4, point 5 until 8. 8 consecutive point up or down. 14 point alternatively up and down. So 14 point you count, point 1, point 2, point 3, point 4 until 14. See whether they are alternating or not. One up, one down, one up, one down. Then rule number 4, 2 out of 3 consecutive point in zone A. Okay, in zone A. 4 out of 5 consecutive point in zone B, zone A or B on one side of the center line. Okay. If any of these guidelines applied to a sample observation in a control chart, it will imply that a non-random pattern exists and the cause should be investigated. Okay. So this is important. You need to give the argument by calculating 1 sigma, 2 sigma, 3 sigma, whether it's in zone C, zone B, zone A, and then you need to tell me whether it's either non-random or random. Okay. So this graph is violated because rule number 1 violated, rule number 4 violated, rule number 5 violated by giving this sample. If you count rule number 1, 8 consecutive points are on one side of the center line. Where are the consecutive points? This one. 1, 2, 3, 4, 5, 6, 7, 8. 1 consecutive point. You count 8. Is there any 8 point continually on one side of the point? If yes, then it violates. This is not random. Not normal. This is not normal. Okay. You violate 1 also not normal. This 5 point. You violate 1 of these also consider not normal. 4. 2 out of 3 consecutive points are in zone A. Here. This is zone A. So there's a calculation to calculate again. So number 4, 2 out of 3 consecutive points. You count 1, 2, 3. 1, 2, 3. Continuous 3. 2 already in A. Violate rule number 4. So again, second rules violate, confirm not random. Number 5, 4 out of 5 consecutive points are in joint zone A or B on one side of the center line. You observe one side of AB. So this one don't need. 1, 2, 3 don't need. 4 out of 5 consecutive points in zone A. You count 1, 2, 3, 4, 5, or you look at this one. Zone A or B. Zone B, you count 5 points. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3 in zone B, and you count A. 1, 2, 3, 4, 5. This one 4 out of 5, either A or B. So if they're consecutive point, 5 on this point in this AB, consider out control. You count 5 point. 1, 2, 3, 4, 5, 6. You can take from this point 1, 2, 3, 4, 5. Out of this 5 point, 4 already in A or B. Yeah. Important, huh? This one important, huh? Pay attention to this one. You need to give reason why it is non-random happen. Yeah. Example 6. You want to see whether there's a pattern test for this one. For example 6, same data, and want to see whether random or non-random. You need to calculate sigma 1, sigma 2, sigma 3 line first by taking sigma x plus 1 over 3 A2 R bar. The second line is 2 over 3 A2 R bar. The third one is x double bar A2 R bar. You need to calculate that one. Okay, you need to build another table for this one. Okay, or you can just go into the chart, draw the 3 line. Draw this one, huh? Go to the chart, draw 3 line, 1 sigma, 2 sigma, 3 sigma line, and then label zone C, zone B, zone A. I seen careless mistake previously. Some student write zone A, zone B, zone C. You write the wrong zone, sorry, you are out of the question. Okay. This is just a side work, side work. So if you plot the graph, you split this one into 3 sigma. You draw the 3 line. First sigma 5.03, 2 sigma 5.05, third sigma is this one. Okay, so sigma 1, sigma 2, sigma 3. Then you use the 5 rules to see whether it is random or not random. Check. You need to list out these 5 rules in your answer. Identify pattern in the control chart. You write 1, rules 1, rules 2, rules 3, rules 4, rules 5. Then you check each of the rules. 8 consecutive points on one side of the center line. Where is your center line? Do we have 8? 1, 2, 3, 4, 5. Okay. 8 consecutive point up or down. So you count 1, 2, 3, 4, 5, 6. Rule number 2 also not. Number 3, 14 point alternating up or down. 14 points. So this one less than 14 points. Number 4, 2 out of 3 consecutive points in zone A, one side of the center line. Zone A is here. So 2 out of 3. 1, 2, 3. 1 and 2 already hit, violate rule number 4. Here also. Okay. On the top, on the top. Number 5, 4 out of 5 consecutive point in zone A or zone B. This is zone A, zone B. So 1, 2, 3, 4. You calculate 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You count 4 in zone B and zone A. 1, 2, 3, 4. Violate rule number 5. So it's a non-random case happen. You need to monitor, you need to change, you need to intervene the process. Okay, in exam, you need to write these 5 things, and then tell me what violate. Okay. Okay, so another patterns on the well-distributed chart. The first one, natural variation with quite balanced left-right. Second one, design specification. So design specification and natural variation of in the same process is capable of meeting spec in most of the time. So it means what? This is the natural variation. Natural variation exceed design specification. So this curve is natural variation, and process, this is your design spec, is within these two lines. So process is not capable of meeting specification all the time. This one, process is capable of meeting specification most of the time because the design spec is fall within the data. Okay. This one, the design spec greater than the natural variation means you see your design here, but your data always fall within the design spec. This is the, you can say this one is your upper limit, lower limit. You always stay within the design specification. This one is your data. You collect data outside the spec already, so not meeting spec. This one, yeah, almost meeting the design spec. This one is some point is out, but it's shifted towards another end. Okay, so this one specification is greater, but the process off-centered, capable, but some output might not hit upper specification. So you need to know how to explain normal distributed graph. What is design specification? Okay, by using these slides. Ah. You turn this graph like this. No. Okay, this on the is always lower. This is upper. Yes, right. Right is upper. Okay, right is upper. Okay. Okay. So this will be a general answer if you look at the distributed data. The following, I treat it as your homework. Lots of information. Go and read. Lots of information. But it's important. So Six Sigma, all these things, go and read. It's a lot of information on. Go and read. But I spent lots of time doing this lah. So go and flip through lah. At least you flip through. Okay. Concurrent, Six Sigma. Some of it we already repeated already. Okay. This chart is very popular if you do IPPDD, Integrated Product Design and Process Development, IPPDD. So this is a wheel for IPP, Integrated Product Process. This one is Integrated Product Development Process. You combine these two, you get IPPDD. We call it concurrent or same time parallel process. This is you can say this one is a quite old model. But if you go to industry, those when you study Six Sigma class or you go to those total quality management system, they will show you this one. Okay, at least you've seen it before in the class, in this class. Okay, I've seen this one. Maybe I forget what it is, but I see two circles before. One is for the process, one is for the product. Okay. Concurrent means you join the two things together by dotted line. Okay, it means you sharing information at the same time. Okay, like for example, nowadays all the software, CAD software you have, we call it workstation. So one work in the America States, one in work in Malaysia. At the same time, if both user open computer or working on the same server, you're seeing the same information. Okay. The rest you read. The laws of theories. Okay. One technical word called Rumbles design. Rumble design means you're designing a product having minimum quality losses. Quality losses means you're designing a good good products. Okay, the rest you read. If you take product management class, you cannot avoid a name called Takuchi. Takuchi is this man, statistician. So statistician, you know lah, distributed graph lah. So Takuchi approach is to do what? Is to use statistics to control process. Like what you do, P chart, C chart, all these things. Okay. The main objective of using Takuchi approach is to do optimization. Okay, to do optimization. Okay. Loss function, you read. Loss function, rumble design phrases. Okay, so this one you read. Read. So this one you already covered. P chart, C chart. What is the control in control? Okay. This one is more detailed in developing the statistic method. Right? We won't go deep there. If you study programming language, then this one will be very important. Input on the left, don't go into the process, then your output. You see this one in your Arduino project if you use Arduino. Okay. On the left is your input, then you program it, you print the report, print the output. The rest you read. Six Sigma again. Okay. DMAIC is define, measure, analyze, improve, control. Just need to remember the acronym. The rest read. This is just a history on product management. Okay. It start from where? Start from industrial revolution when the machine was developed. Use steam engine, railroad, automotive, supermarket, Honda, Toyota, Ono. This is start to use lean production. Then Walmarts and so on. And so on. From 1770 until 2000. Okay. Okay. So this is just an application of lean production. Go have a read. Example 5. Lean Sigma. Okay, go and read. This one, probabilities. Quizzes. Go and have a look. All this you read. This one also, go and have a look. What is 5S? Because when you go to internship, you'll sure come to 5S things. What is 5S? 5S is set in order, shine or clean, standardize, sustain, and sort. Okay, this is 5S system. Go and read all these things. Okay, Pokayaki, also important when you do to industry, go to your internship. Don't say you don't know what is Pokayaki, especially you talk to your production manager. Pokayaki is go, no go, or Pokayaki in translate is mistake proven, or in a very bad word is anti-idiot or idiot proving. Means you avoid become an idiot. Okay, for example, Pokayaki, your SIM card, there will be a edge there so that you know where to insert. Okay. So all this lah. So Pokayaki, 3 types of Pokayaki. Quite common nowadays common when you talk to industrial people, especially production design. You should know this one we already like common sense already. If you go into the production floor, you don't know what is Pokayaki, then people will laugh at you. What you're doing with your engineering degree. Okay, so type 1 is more on a contact. Second one is you use fixed value. And the third one is motion steps. Okay, so type 1 Pokayoki means you use physical shape, size to control, right? Fixed value, this one, type number 2, operator is alert if proper numbers of movement are not made. So this one, fixed value is, for example, your phone, you know how to reset your phone, right? Force reset. You press all the button, right? That one is also Pokayoki approach. Means you set the fixed value. If 111 means the button you press is programming is 1 and 0. So if you have 3 1 in the button, then the system will know you actually want to reset the things. Okay, this one, third type of Pokayoki, you use motion, means this one you must follow the procedure. And for example, what? Motion steps. Can you think one of the example, Pokayoki? Anything that you use that must follow a certain procedure. For example, ATM machine. You must insert your ATM card at a certain orientation. If not, then it will reject. Then after that, you ask for your pin. If you key wrong pin, it will also reject or it will eat your card lah. Something like this. Motion steps. Okay, so this one you read lah. Example of using Pokayoki of a screw scenario in a factory. Okay. So this one you read lah. Six Sigma, these are the things that might ask you, right? What is 5S? How you apply 5S? Okay. So this one might be one question of 5 marks. Ask you how you apply 5S in the certain situation. We only want you to mention step 1, sort, then elaborate how you do the sort. Number 2, strengthen, how you do the strengthen. Number 3, sweep or clean. Number 4, standardize. Number 5, sustain. Right? Then you elaborate. Pokayoki, you ask you to give example of a Pokayoki case study. Right? So again, you have 3 types of Pokayoki: contact, fixed value, and motion step. Go and look for information. This Pokayoki. We like to ask you something like this, and then we want to see you to do some thinking, like how you apply in your daily life, or how Pokayoki can help you to solve some problems. Okay, especially this example. Go and see these slides. Okay, it gives a scenario, then use Pokayoki to solve this problem. Yeah, go and read. Okay, the rest you read. There are lots of information. Okay, so since this is a table, the question might ask you, tell what is the differences between the past and present view on quality. So there's 1, 2, 3, 4, 5, 6, 7, 8. Maybe 3 points from the past, 3 points from the present. Okay, so pay attention to this table. Rest you read. TQM, repeat again. Okay, quality. Plan, do, check, act. This one also very popular. Deming cycle. So go and read. What is Deming cycle for improvement? Elaborate Deming cycle by using this illustration. Go and read what is Deming cycle. Okay. Joran, what Joran thinks about quality. Go and read. Okay, so this table is important. It will tell you to elaborate on various approach to quality improvement. These are the gurus or expert. The first column is Deming, 14 point. Go and read. Joran, 10 steps, 1 to 10. Hospi, 14 step, 1 to 14. So this one also very popular in final exam or maybe test 2. So either one of these will come out in one of your tests. Okay. Okay, the rest is to read. So this one you did seen before, the cause and effect analysis, histogram, Pareto. Okay, so these are the things that if you do report, these are the correlation that you need to know how to elaborate in your graph. So this one, no correlation means is jump here and there. Collinear correlation means you see a curve there, you can plot a curve. This one, straight line, go down. Negative correlation means your M is negative. Y equal to MS plus C. M is negative. This one, Y equal to MS plus C. Your M is positive correlation. Okay. So these are the things that every time you have lah. Okay. Trend analysis, you're quite common. Control chart. Okay. So previously P chart, C chart, mean chart, R chart. You learn about mean, upper limit, lower limit. Then there's one table just now that mentioned about specification. Okay, specification limit. So the purpose of putting specification limit is to ask you to describe whether the data is within the spec limit or outside the spec limit. Okay, the rest you read. Okay, go and read this one, type of control chart and application, variable chart and attribute chart. What are those? Go and read. Okay, this one will be done. This one you read how to do sampling. You go out there, people mention Six Sigma. You must know that Six Sigma is first introduced by Motorola. So especially when in your conversation group, someone from Motorola, you need to know how to talk. When you mention Six Sigma, don't mention some brand if some Motorola guys is inside the conversation circle. Six Sigma again, Lean Six Sigma. This one you read. Okay, Okayoki again just now. Principle, make wrong action difficult, make mistake obvious, detect errors. Detect errors. So example of seat backs, plugs, the USB connector, all these things. I mean cannot go wrong. Your heart, your heart actually is Pokayoki natural design. The blood can only go one direction. It cannot reverse back. Okay, so remember that Pokayoki, your body actually is one of the best design, especially your heart. And nowadays you have poka-yoke in all the sensors in the smart cars. Quality cycle, go and read. This one also go and read. Okay, so go and do the quiz. Go and do a quiz. Okay, a little bit more. Okay, number 5, Rumble's design. Again, Rumble's design is to loss. So you can see method of designing or conducting experiment to improve the performance of the products. So from this design until the Rumble's design, okay, it changed to the maximum optimization process, okay. Or in SolidWorks, you've seen the function is topo something. Okay, there's a function. Okay, go and read. Go and read. Rumble's design. This one a lot lah. Too many information. Okay, Rumble's design process, 7 steps. Just memorize. Identify, formulate, develop, run experiment, do analysis, confirm, and then reflect. The rest you read. Lots of information there. 7 steps. Blah, blah, blah. Go very fast. Design of experiment. Go and have a look. Okay, with this we conclude chapter 8.